Here we go. So as you can recall, Mr. Dalton came up with a law. Do you remember what his law was?
Definite composition.
Okay, one of us knows it at least. Okay, law of definite composition. And what he did is, among other things, he decomposed water into its individual what? Atoms. And he noticed that no matter how much of the water molecules he decomposed, he always noticed one thing. What was it?
They all are the same ratio.
By what?
Mass.
By mass. Okay? This led to later chemists realizing that every compound is made up of the same exact atoms, same ratio of atoms every single time. Okay? So they decided we need to come up with some sort of standard. Remember, any measurement is really just a standard, right? And they needed to come up with a standard to measure an atom. To measure the weight of an atom. So, you know what I gauge? This 5:30 morning. You didn't. Were you even here?
No, he was at 5.
What in the world are you tired for, then, bucko?
He was doing something else at 5:30 that will go on set.
Oh.
What? I met up
With?
Jackie Carnate in the morning.
What?
Wait, what?
All right. A little early morning cuddle session. I get it. I get it.
A friend.
Hey, you're on camera, Kramer.
I know. I'm just.
Friend.
I know how you high schoolers do it. I'm not saying it's right. I just
I went with my sister.
Now that is a good. That's like courtship 101. Smart man, right there.
Yeah.
Smart man. What'd you say?
You had a cuddle session?
It
No.
was a joke. It was a joke.
I'm lost.
Yeah.
It was National Day
teach
Coffee
us.
River.
Oh, okay. All right. So here's what happened. These guys came up and said we need to figure out or derive some unit that can help us measure the mass of an atom. And here's what they came up with: the elusive atomic mass unit, abbreviated U or AMU, AMU. Okay. Here's how it's defined. An atomic mass unit is currently defined as 1/12 the mass of a carbon-12 atom, or approximately, wow, really small.
So currently, so you mean it could,
Well, they could if they wanted to. I don't think they're planning on doing that anytime soon.
yeah.
Okay, but here's how they did this. Essentially, an atomic mass unit is the mass of one proton.
Okay.
How do I know that based on this definition?
Because,
1/12 of a carbon-12 atom.
And we know that 12 represents what?
The atomic mass.
No.
number of protons.
The
I mean, no.
What's this number, guys? Don't forget about it for
Mass
yesterday.
number.
Tanner, are you paying attention at all right now?
I said
Mass
mass.
number.
Mass number, which is what?
Hey.
Get 'em.
Oh.
What's that do to you? Well, I decided either this or your head. This was probably the safer bet.
Honestly, probably.
Ah.
My head's in the block.
Now, what this is the mass unit, which is the number of protons and neutrons. Okay? 1/12 of that would be really just one proton or one neutron. And last time I checked, the mass of a proton and neutron are relatively what?
The same.
The same. Okay? And so then why don't they take into account the mass of the electrons when they measure the mass of an atom?
Because the electron is drastically smaller.
Yeah, the electron's drastically smaller, and if I've got like 1 and I add 0.00001 to that, it's still basically what? 1. So it's kind of like that same idea here. So really what atomic mass unit is really just the mass of a proton or a neutron. And that's a really small number. That's kilograms we are familiar with. That can kind of show you how small of a mass each of these protons and protons and neutrons are. Real small. Okay, so when you look up here, you see that it has an atomic mass of 12.011. Well, let me ask you this. If the atomic mass unit is really the mass of a proton, and we know a proton and neutron, approximately. And we know that this carbon atom has 12 protons and neutrons. Why is that not just 12?
Because of the element.
No.
What?
Why is that not
Because
just 12?
every atom is different.
What do you mean every?
Sizes.
Why? How?
Is that the average?
What did we just talk about yesterday?
I don't remember.
That's clear based on some other things that I've asked.
The gram, that number is how.
Look back in your notes. What's the number, the very first definition in your notes yesterday? Isotopes.
Oh, okay.
And what are isotopes?
One's without the same.
The neutrons are different. Okay, so this is just one of the carbon isotopes. Could I have a carbon 13 isotope?
Yeah.
Could I have a carbon 11 isotope?
Yeah.
So how in the world then do I figure out atomic mass if really isotopes tell me that each carbon atom could be a different mass? Here's what they did. They figured out approximately the percentage of each isotope that appears naturally in nature. And they took a weighted average of it.
Wow.
That's where they got those numbers on the periodic table. Almost none of them. Some of them are whole numbers. The radioactive ones are whole numbers because they're so short-lived and there's only one form of them. Okay? But almost every other guy that we know of is not a whole number because every other guy has multiple isotopes of each atom and therefore different masses within each atom. So I cannot just take the whole number definition of this atomic mass and call it good because I've got some carbon atoms that have 7 neutrons, and some carbon atoms that have 6 neutrons, and some carbon atoms that maybe have 5 neutrons.
So is the Pt1 radioactive? Because it has a.
Which one?
The-
It's not radioactive, but it's possible that it just only has one isotope,
Oh.
one type.
Oh, okay.
Does that make sense?
Yeah.
Okay, so here's how we're going to do this. We're actually going to compute the weighted average. This is how, if you guys want to know why your grade is the way it is in my class, you can take the weighted average and figure it out. Because I grade based on averages. What's weighted more? The tests are weighted most. They're 55% of your grade. Homework's 25% of your grade, and quizzes are 20% of your grade. I actually had a parent asked me, he was like, well, if you add all the points together, my kid has a 96%. Why is it that my kid has a 90% of your class? And I had to explain all of that to the parent. Okay? So here's how we do this. You take your percentage, so like for my situation, 55%, and I turn it into a decimal for tests. I can take my homework, 25%, turn it into a decimal, 0.25. I can take my homework percent, turn it into a decimal, 0.2. That's what the first one says. Then multiply your decimal percentage by the mass of each individual isotope. And I'll show you, I'll go through one example here in a sec. Lastly, add the results to get the weighted average. So, let's do it.
So, do we add up them all and then divide by 1 or 2?
Let me make this smaller so I have more room. Alright, so here we go. I think you got a place to follow along with this. Yeah? You don't need a calculator. Okay, first thing we gotta do is we gotta take each of these percentages and turn them into a decimal. Now look, if we read this problem, it tells us that the element magnesium appears in 3 naturally occurring isotopes. The first isotope is a magnesium-24. How many neutrons does a magnesium-24 atom have?
12.
12.
Yes.
How about a magnesium-25? 13. And a magnesium-26? 14. Okay, which one occurs the most?
The magnesium.
25. My guess is the magnesium number is closer to the 24.9. 24.3. Because most of magnesium is in that form. Okay, so let's do this. Start with the first guy. Let's go with the magnesium 24. The percentage of that occurs is what?
78.
78. How do I turn that to a decimal?
Move the decimal to the left.
Decimal to the left twice. Okay, there's your percent. And then it says to take your percent as a decimal and multiply by your what? Do you remember? These are rules. Multiply the decimal percent by the what? Mass. So here's your decimal percent. Right, there's your percent in the decimal form. I'm going to take that. I'm going to multiply it by my mass, my atomic mass here. And then it says to take all, when you do this for all three, you add them all together. So I'm going to start doing that now. Little plus sign there. What's my next percent?
21.
Put 1.
Yes.
So I'm going to multiply that by its what? Its mass.
Which would be 24.
Yeah, you gotta be careful how you read this, because there's a comma. That percent's referring to that mass. Did you just mess that up, Tanner? Or you gotta sneeze?
I feel like I need to.
Okay? Times 24.986. And the last one, we got 11%. Times its atomic mass. The what? 25.983.
Well, there you go.
There you go. What do you get?
There she is.
Oh, there it is.
There she blows. 24.30, approximately 24.3043. That's what I got. Did I even do that wrong?
Well, I got 305, like that
Oh,
one.
798. Yeah, it's the same as the number up there.
Why did you point?
That's good.
Yeah.
Well, what do you round it up to 1 instead of the last 6?
Run up to
Because it's a 7
I
What
don't
does
know.
it say?
Well, now I can say that I kind of know what all the numbers mean.
Yeah, so these numbers aren't whole numbers because of the isotope factor.
What about the little ones to the right, the plus something or other?
That's the charge or the oxidation number needed to be stable. So like this has 1 valence electron, it will lose 1 electron to drop the energy level and have a full
Oh,
oxidation.
that's right, that's right. I remember. Okay.
Yep, we will talk much more about that this chapter. Okay, any questions on this? And I need a unit, shame on me. U or AMU, I don't care. Would be your answer. That would be your atomic mass of approximately 1 magnesium.
Yeah, why
Do we have a worksheet?
Why do I what?